Okay, Matthew and Chase, also, if you need to watch this, we're going to start off with the rest of the review sheet. This should be the second video you've been able to watch. Let's start off with this first page right here, which is page 483. Numbers 18, 22, 26, 30, 32, 37, and 47. Matthew, you should have this written down already when I gave this review sheet to you. But anyways, just in case you do not, that's the first page we're going to look at, okay? So with that in mind, let's go ahead and start off with number 18. So go ahead and open your book and go ahead and let's get to work, okay? We have e to the negative 3 times e to the fifth. Now, if you look at the directions, it says simplify the expression. It does not say evaluate. And on the test on Thursday, let me pause and say this right now, Matthew. Thursday's your test. You have 2 videos to watch, okay? I emailed you one already, and now I'm going to email you this one, okay? It is your job, it is Michael's job, it is Chase's job to come into class Thursday ready for your test, okay? Now, I'm not telling you you can't ask questions. I'm just telling you this. You're hurting yourself if you have questions because you're losing test time, and then you have to take the test home over the weekend, and you've got to bring it back Monday and turn it in completely done, or you lose points on your test. So I'm just telling you, you really need to be ready for your test on Thursday. So when you walk in the door Thursday, we're taking our test. Now, having said that, if you have some questions, that's fine. But if you don't finish your test, you must finish it over the weekend. So here we go. Anyways, having said that, on the test, I would tell you whether or not I wanted you to take it further or not. In this case here, whenever you're multiplying like bases, you write the base once and you add the exponents. And so that's the answer, okay? That's pretty simple. Let's go ahead and take a look at the next problem, number 22. That's as far as I'd want you to take it right there. You could type that into your calculator and get out a number. I don't want you to do that. Okay, now be very careful on this next one. This next one is not easy. It's 1/4 e to the negative 2. And all of that whole group is increased to the negative third power. Now please watch my steps and see if this makes sense. You know already that you're going to take the negative 3 and multiply it through. So you should know for sure that you're going to have e. And I apologize, Matthew, this is a positive 3 right here. Let me fix that real quick. This is a positive 3. There. Okay. You know, first of all, you're going to have e to the negative 6. Okay. 3 times negative 2. But don't forget, there's a 1 with a 1 and a 1 with a 4. So 3 times 1 would give you 1 to the third power, and 3 times 1 here would give you 4 to the third power. Think about that for a second. That makes total sense, okay? This 3 goes to every exponent on the inside. So now what I have is this. 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. And really, this e to the negative 6, you can look at it like it's over 1 if you want to, however you want to look at it. But that e to the negative 6 is really up top here next to the 1. So e to the negative 6, okay? And again, the reason is these two are being multiplied. And if you want to look at this like it's over 1, that's fine. That would put the e to the negative 6 up top. Okay? So now the last step that you have to do is simply take this e and bring it down to the bottom. And when you bring the e down to the denominator, your 6 becomes positive. So there we go. Moving on to number 26. Number 26. All right, 26 is e to the x times e to the, or 4e, excuse me, 4e to the 2x plus 1. Now, let's simplify. Here we go. What's in front of this e here? A 1. So 1 times 4 is 4. That's easy. And then whenever you're multiplying like bases, e and e, you write the base once, and you add the exponents. So you have x as your exponent plus 2x plus 1. I'm adding my exponents together, all right? And when I do that right there, I should get 3x plus 1. If you take x plus 2x plus 1, x plus 2x is 3x plus 1. And that is your final answer, all right? All right, moving on to number 26. Number 30. Number 30 is next. All right, 30 is this right here. We have 32e to the negative 4x, and all of that is raised to the third power. So we're going to take that 3 and multiply it through. Now don't forget, the 32 has a 1 with it. So I would really have 32 to the third power e to the negative 12x, 3 times negative 4x. Now we never want negative exponents, so the 32 to the third stays up top, and we bring the e down to the bottom, and that makes our 12x positive. Now, for the numerator, if you want to take 32 and take it to the third power, that's fine, but you don't have to do that. All right, moving on to number 32. Number 32. Okay, it is the cubed root of 64 e to the 9x. Now here's what I've taught you to do. First of all, if you know the cube root of the coefficient, you take it, and we do know the cube root of 64. So I'm going to cross off the 64 and put a 4 on the outside, because the cubed root of 64 is 4. 4 times 4 times 4 is 64. And now what I've taught you to do is you take this, whenever you have e or a variable with a power, remember what to do, Matthew? You take the power and you divide it by the index. So 9x divided by 3. Well, 9x divided by 3 would be e to the 3x. So you would have 4e to the 3x. And the radical is totally gone. You took the cube root of 64, 4 is on the outside. The cube root of e to the 9x is e to the 3x. And so the radical is totally gone. All right, that was number 32. Let's take a look at number 37. 37 is nothing more than a calculator problem. And let's take a look at it here, 37. All right, e to the negative 1/4. Well, you would hit your e button, and when you do Matthew, e should pop up with an arrow and then a parentheses. You would then type in negative 1 divided by 4 and close the parentheses. All right, now I'm typing that in right now to see what I would get. So e negative 1/4, you would get 0.7788, and that's rounded. All right, now let's take a look at the next problem, which according to my notes is 47. Number 47. All right, so 225 e to the negative 50. Now I'm not sure why they use such big numbers, but anyways, go ahead and type in 225. Then hit your e button. The e will pop up with an arrow and a parentheses. Then type in negative 50 and close the parentheses. And your screen's going to say this, Matthew. It's going to say 4.33968716e to the negative 20. All that means is this. Just put 4.3 times 10 to the negative 20. That's all that means is scientific notation. I will not give you on the test that comes out like that. So just know how to type it in. That's the main thing, is know how to type these in. All right. Okay, that was one page. The next page that we're supposed to do on your review sheet is page 490, 49 through 55 odd. 49 through 55 odd. Let me turn over there in my book, and here we go. 49 through 55 odd. Okay, we're simplifying these expressions. Let's start off with number 49. Here we go. 49 is log 2 base 2 of 2 to the x. Now here's the property I taught you, Matthew. I said whenever the base of the log matches the base of the exponent, everything cancels out and your answer is just the exponent. So the answer to that is just x, whenever the base matches the base. There's nothing else to do on that. There's no work to be shown. It's just memorizing a property. Okay? Number 51, 35, and then 35 has an exponent, and that exponent is is log base 35 of x. Now this property states this: whenever the base of an exponent, that's 35, matches the base of the logarithm, 35, everything cancels out and your answer is just the argument. And of course, in this case, the argument is x. So the answer is x. You might need to rewind these and watch these a couple times. And if you do, that's fine. All right, number 53. Same problem, 7 log base 7 of x. Whenever the base of your exponent matches the base of your logarithm, your answer is your argument. Everything cancels out, so your answer is just x. And then last but not least, number 55. And actually I'm going to go to a new page for this because this is the toughest out of all 4 of these. So page 55. The problem looks like this: log base 20 of 8,000. Now, I don't see any matching bases or anything. Oh, 8,000 to the x power. But I want to show you this. 20 to the 3rd power equals 8,000. Now, how do I know that? Well, look, Matthew, I know they're not going to give us a problem we can't work out. I know I want to have some like bases. And I know that 2 to the 3rd power equals 8. So if I start adding some zeros, I can probably see that 20 to the 3rd power equals 8,000. So see this 8,000 right here? 8,000 equals 20 to the 3rd power. So where that 8,000 is, I'm going to make a substitution. And where 8,000 is, I'm going to put 20 to the 3rd power. So that's what I put for 8,000. Then bring your x down. All right? And now I have 20 to the 3rd power to the x power. So real quick, I want to simplify that. That would be 20 to the 3x power. Now I hope you see where that 3x came from, 3 times x. And now look, whenever the base of your log matches the base of your argument, the answer is just your exponent. So all of these cancel out, and your answer is 3x, okay? All right, I hope that was a help to you. Now we're going on to page 491. Numbers 59, 63, 67, and 73. All right. So with that in mind, let's go ahead and start off with number 59. Number 59. All right, number 59, we're going to write the inverse of this. So y equals log base 1/2 of x. Are you ready? Let's write the inverse function of this logarithmic function. Step 1, everywhere there's a y, you're going to put an x, and everywhere there's an x, you're going to put a y. All right, step 2, we're going to write this from logarithmic form to exponential form. So remember that formula? I'm going to erase it here in a second, but we learned this a long time ago. Log base a of b equals c can be rewritten as b equals a to the c. A to the c power. We learned that way back at the start of the chapter, okay? And so it's written logarithmically. I'm going to write it exponentially. So it would be 1/2 this whole fraction to the x power equals y. Now you know you're done because y is all by itself. So you have written the inverse function of this function up here. All right, let's take a look at number 63. Number 63 is next, and 63 is this: y equals natural log of x plus 2. Now, we're going to write the inverse of this function. Everywhere there's a y, we're going to put an x, and everywhere there's an x, we're going to put a y. There we go. Now, step 2 says write this exponentially. Don't forget, whenever it's a natural log ln, the base is e. So there is a base e there, even though you can't see it. So we're going to write this from logarithmic form to exponential. So you bring the e over. When you bring the e over, it's e to the x. And then you'd be left with y plus 2 over here. That's called writing it from logarithmic form to exponential form. Again, it's back to that formula we learned before. Log base a of b equals c is the exact same thing as b equals a to the c power. Okay, we learned that a long time ago. Okay, now y is not by itself yet, so you're not finished. Subtract 2 from both sides, so e to the x power minus 2 equals y. Okay? Now you know you're finished because y is all by itself. Now let's take a look now at 67. Number 67. And here we go. We're going to graph this logarithmic function. So y equals log base 2 of x plus 1. Now, here are your steps. Step 1 is take the argument and set it equal to 0, and this will give you your vertical asymptote. Now, Matthew, the argument is not x plus 1. If there was parentheses around it, then your argument would be x plus 1. Your argument is just x. So you take your argument, set it equal to 0, and solve. There's no solving to do. So your vertical asymptote is at 0. Alright, step 2. You take your vertical asymptote, which is 0, and you put it in the top of your table of values. And then you type this into your graphing calculator. Now the problem is, Matthew, is your calculator does not do base 2. So when you type this into your calculator, go ahead and hit your y equals button. And when you do, here's what you're going to have to type in. You're going to have to type in log of x, and a parenthesis is going to pop up, and you put an x, and then hit divided by, and then log, and then the parentheses will pop up. You put 2, close the parentheses, and then plus 1. Remember, that's called the change of base formula. Your calculator does base 10 and base e. It does not do base 2. So in order to conform this, you're going to have to write log of x divided by log of 2 plus 1. So that's how you should type this into your calculator. Okay, now I'm a little behind, so give me a second while I type this into my calculator. Alright, log of x divided by log of 2 plus 1. Alright, let's take a look at our table of values here. And if you'll look, 0 gives you out error, which is fine. And then you know not to put a -1 and a -2 because all of those are errors also. So we're going to go 1, 2, 3, 4. And so 1 gives you out a 1, 2 gives you out a 2, 3 is a 2.5, and 4 is a 3. Now, let's go ahead and graph this very quickly. Don't forget to put your vertical asymptote on the graph. It should be a dotted line. Of course, it's vertical, so it's going to go up and down. So here's your vertical asymptote right here. It's a dotted line going up and down at 0. So the graph will not intersect that asymptote. Now we have 1, 1, 2, 2, 3 is 2.5, and 4 is 3. So you can see the curve taking place here. And then it starts curving down, getting closer and closer to that asymptote, but never touching it. Now, think about the domain. The domain does have a boundary. Domain deals with right and left. Well, yes, it continues to the right, but there's a boundary here to the left. So your graph is x is greater than 0. Think about it. Here's 0 right here. Your graph is to the right of the asymptote, so the domain has to be x is greater than 0. Now the range is all real numbers because it continues, as it goes to the right, it continues to go up, up, up. And as it goes to the left, it continues going down, down, down. So the range is your up and down movement, and that's all real numbers. All right, 2 more problems left, and we're done with the whole thing. All right, number 73. Let me grab a quick drink of water. And here we go, number 73. Y equals log base 5 of x plus 4. Alright, step 1, we take our argument, x plus 4, set it equal to 0 and solve. X equals -4, so we know we have a vertical asymptote at negative 4. Now, I put my vertical asymptote at the top. Now I'm going to type this in my calculator. Don't forget, it would be y equals, and then log, up pops the parentheses. You would type in x plus 4, close the parentheses, then divided by, hit log, up pops log parentheses, put a 5 in, and close the parentheses. Okay? That's exactly how you should type it into your calculator. Please give me a second while I do that. Alright, and here we go. Please notice for negative 4, your table of values gives you an error, okay? And you know you don't want to put negative 5 or negative 6 because they continue to give you error also. So we're going to use negative 3, negative 2, negative 1, and 0. So negative 3 gives you out a 0. Negative 2 is 0.43. Negative 1 is 0.68. And 0 is 0.86. Then I'll go ahead and throw a 1 in here just for the fun of it. 1 gives you out a 1. Alright, here we go. Alright, negative 3. Let's put our vertical asymptote on here. It's at negative 4. So, negative 4. That's your vertical asymptote. Okay, negative 3, 0 is 1 point. Negative, sorry about that, excuse me. Negative 3, 0 is right here. Negative 2.43 is right there. Negative 1.6, 0.86, and then 1, 1. So it's increasing very gradually as it goes to the right. And then of course it's coming down like this. Well, again, the domain is all to the right of negative 4. The whole graph is to the right of your asymptote. Your whole graph is to the right of negative 4, so your domain is x is greater than negative 4. The range, of course, continues going up and continues going down, so there is no boundary for your range, so it's all real numbers. Alright, hope this is helping. We have one more problem. It's on page 521, number 43. Page 521, number 43, and we're done, so not too bad. Alright, here's the problem. 9 over 1 plus 5 e negative 0.2x equals 3/4. Now, Matthew, I want to kind of jog your memory. Let me check and make sure I copied this correctly. You learned something way back in elementary and middle school. Hopefully you didn't forget. And that is, whenever two fractions are equal, you can cross multiply and set them equal. So in other words, I can take 9 times 4, which is 36, and I can take 3 times this whole expression right here, and I would get, well, 3 times 1 is 3, and 3 times the coefficient of 5 would be 15 e to the negative 0.2x, and I can set them equal. Okay, so whenever you have a fraction equal a fraction, you can cross multiply like we just did and set them equal. Now, please look carefully, Matthew, at what I have. I have an unknown in the exponent. My unknown x is in the exponent. What's the base of that unknown? E. I want to keep those together, okay? So there are two numbers I want to get rid of. I need to get rid of a 3, and I need to get rid of a 15. So in order to do all of that successfully, I'm going to subtract 3 from both sides. That leaves me with 33 equals 15e to the negative 0.2x. Now next I want to get rid of the 15, so I'm going to divide both sides by 15. So I'm going to take 33 and divide it by 15. I'm going to get 2.2. And I divide this side by 15. The 15's cancel. I'm left with e to the negative 0.2x. Do you see what I did? I divided both sides by 15. Now, here's where it gets really tricky, so please pay attention, okay? Here we go. Now watch this. Notice my unknown is an exponent. Notice I've isolated the base and its exponent. You remember what I taught you to do? What is the base of your unknown? Here's your unknown. What's the base? E. Whatever this base is, it could have been a 5, it could have been a 10, it could have been a 2. In this case, it's an E. So I'm going to write log base E, leave a little space, put an equal sign, and then put log base E. Now look, students, if this E right here would have been a 4, then I would put log base 4, log base 4. Whatever this is right here, that's what I always put here and here. Okay, moving on. Now you bring down your whole left side, so log base E of 2.2. You bring down your whole right side, so log base E of e to the negative 0.2x. Now, do you see why I've done that? Matthew, you should see right here, look what I have. I have a base that matches the base. Whenever the base of the log matches the base of the argument, everything cancels out except for the exponent. So I'm left with negative 0.2x. And over here I have log base e of 22. Now, next I want to get x by itself, so I'm going to divide both sides by negative 0.2. Now, if I divide this side by negative 0.2, I'm left with x. If I divide this side by negative 0.2, I'd have log base e of 22 all over negative 0.2. Now, please watch this, Matthew. Don't miss this. Whenever I have a base e, a log base e, remember that's the same thing as a natural log. And this should be a 2.2, 2.2, 2.2. Let me say that again. Whenever I have log base e, that's the same thing as natural log. So log base e of 2.2 is the same thing as a natural log of 2.2 divided by negative 2. Now on your calculator, you should be able to find a natural log button. That's your ln button. So you would take ln of 2.2 equals, and I'm rounding, of course, but I'm getting 0.7. My computer's really messing up, so sorry about that. 0.7885 all over negative 0.2. Negative 0.2. All right. So let's take 0.7885 and divide it by negative 0.2, and you should get out negative 3.94. So negative 3.94. Okay, hope this has been a help to you, Matthew. Your test is Thursday, and it is your job to be ready for that test on Thursday. Okay, call or email if you have any questions.